Hey everyone, how you doing today? Having a great day? I'm enjoying being back at All Things Open in person for the first time in a while. All right, it's feeling wonderful. I have 15 minutes. I'm going to be talking to you all about the observability best practices for shifting your software, observability best practices for shift-left software development. So I'm hopping to it. I haven't done this in 15 minutes before, so let's see how it goes. Legal's a thing, so I have to put this in here, or they will, throw things at me when I get back to the office. Basically, this is just saying we can't trade on any of the things that I'm going to speak about, but nothing that I'm talking about is actually worth trading on. All right, so if you ask any developer, 90% of the time, they're going to say that they want to spend most of their time building things that they love, or we want to spend our time building things that we love. Actually, we probably spend 100% of our time building if we had the opportunity to. But problems arise, and it's something that we can't necessarily avoid. And throughout my career, I've heard things like this, right? It worked in dev, it's not my problem, it's ops' fault now, right? Well, that's true until you get into some of these modern organizations and things begin to change, right? You go from you build it and you give it to ops and it's their problem to now, like at New Relic and some other companies similar to Amazon, it's you build it, you run it. You're responsible for developing it, for maintaining your infrastructure, for understanding what's going on with regards to the applications and services that you're running. And it's no longer ops' fault, right? It's this scaling responsibility of engineers and what being an engineer means. So in this talk, I want to talk about how you can start thinking about the way that your applications and services are performing and impacting your customers. Oh, what happened? Oh, there we go. My little remote control stopped working, so I'm gonna have to do it without it. All right, and so I want to talk about some of the things that are changing in the landscape for engineers and how we can start thinking about our observability practices earlier in our software development lifecycle, right? So as an engineer, we're expected to ship software faster. The applications that we're building are becoming more modern and more distributed. We're also expected to drive outcomes and do all of that with creating less bugs and dealing with less errors. And so problems arise, and fixing problems are going to be a part of an engineer's life. And at the moment, you have teams that are responding reactively. There's a lot of noise that you deal with, or you're in a situation to where you don't have enough context because we haven't thought about how to handle some problems as they arise early enough in the process in order to actually have access to that data to make decisions or fix issues. And I feel like I said a lot of buzzwords, and there may be questions like, well, what is observability, and what is shift left, or why would I do any of that? So I want to talk through some of that before I continue to move forward. So the concept of observability is using the data that's being created by your software, your applications, your infrastructure to understand its current state of performance and then make decisions about how do you move forward, either triaging and fixing issues or doing things like delivering new features in your roadmap. So it's understanding your application's data and then making decisions off of that based off of the data that's being provided to you from said application. So to give you an example of that, you can think of it as your dashboard on your car, right? Everything you want to know about your car for the most part, you can see based off of the gauges that are presented to you. And that's in concept what observability is. And the plane would be all the switches and lights and bells and whistles that a pilot's using to understand the operations of a plane. With software, it's data like metric events, logs, and traces that we use to understand the true idea of performance and getting an insight into what's happening in our environment and the way that these software applications are actually speaking with each other. So those are going to be the types of data that we use to understand the performance of the systems that we're either building or operating, and they'll let us know what's happening and why it's happening. Shifting left is when you start to think about some of these principles a bit earlier in the process. So as you develop software, you go through multiple phases. You have your design phase that leads you into a build phase, and you do testing, you deploy, and then traditionally you would monitor and you'd analyze your performance after you've deployed your applications in production. With a traditional model, you'd see that some of the thoughts come in, or thoughts around the way that you actually provide quality or the way the application's running come way later in the process. And this idea of shifting left is starting to think about things like observability, performance, customer experience, security earlier in this process, pulling them forward, right? So starting to think about all these things in your design and planning phase and starting to implement some of them as you're building that software. And the reason that you want to do this is you can see that errors start to increase over time, right? So if you're thinking about this much later, you're already starting to experience errors, or your users are starting to experience errors, and you're providing poor customer experience. So that's the value of shifting your either observability practices left or your security practices left. It allows you to start thinking about them a lot earlier in the process, especially when you're paying a bit more attention to quality and detail as you're mapping things out. And that will look like this: moving monitor and analyzation security from that very tail end into your plan and design or your build and develop phase. So you can also be testing things along the way. Eventually, you want to create a system that looks something like this, right? You have your front end and your back end services, your infrastructure, your databases, all the things that are required in order for you to actually build and run software, whether that's something that you develop, it's open source technologies, but it's all working together to deliver features or particular apps and services into the public for whether it's external users or internal users. We have data that we understand that each of these applications are outputting for us to know what's going on with regard to the performance. You implemented things like SLOs and SLAs, right? So I have an objective that I want to meet, a quality of service that I'm trying to provide my users with, and then my company or my product is being held to a certain standard. I want to make sure that I'm hitting that, or going back early in the process to do this cycle over and over, trying to create more reliable software that provides the best user experience possible. More words that I said, right? Latency, traffic, error, saturation, these are going to be some of the main signals that you use when you're getting started. So latency is the amount of time the application is taking to respond. Traffic is being able to manage the demand that you're experiencing. Errors is whether your requests are succeeding or failing, and then saturation is how much capacity is one service getting at this moment. Do I need to be able to scale? Am I handling load properly? And we call those golden signals. And I've spoke about SLAs, SLIs, and SLOs to kind of level set what that means. Your SLI is going to be an indicator of this is the current state of performance. Your SLO is the objective that you want to hit. And then that SLA that's the agreement between you and user or a business and its customers, right? So putting that all together, it's saying that this should be true this amount of time or else, right? We're going to cancel our contract and go somewhere else, or you actually owe me some of my money back. So 99% of my orders should process successfully at least 50% of the time, or something went wrong and now you're responsible for that. So that's what SLIs, SLAs, and SLOs are, and they're a key part of operating successful software in today's modern applications. All right, so what I want to provide is a roadmap on some of the things that you can be doing through these different stages of your software development lifecycle to start shifting some of your observability, and the same goes for security practices left. So in starting in your design phase, observability practices don't start with the deployment of an agent or instrumentation or adding things like OpenTelemetry to your applications. It really starts with the pen and a pad. It's understanding your complete stack. It's getting the right key stakeholders to the table, talking about what reliability means to your organization, and then getting a true understanding of what your company SLAs are, right? So we're providing this quality of service to our users, or we're being held to this standard. And that's normally going to be within your MSA, right? So it's a legal agreement between your business and your users. And the thing about an SLA is that even if you're not operating in a space to where you have this MSA agreement between a company and the users, as soon as someone starts using your product, they expect a certain level of performance, or they move on to the next project. And what we ultimately want is to scale. We ultimately want to provide our users with the best experience possible. And so that's why this is an important starting point in that plan and design phase, to really get an understanding of what does reliability mean and who do I need to work with in order to make these things possible. What does my stack look like, and start breaking them down into understandable chunks. From there, you'll shift into your actual develop and build phase, right? And the things that you want to do as a part of this step is go from understanding your roadmap, understanding your SLA, identifying the stakeholders, and then getting access to your data, right? So now that I know the applications and services that I'm running, what do I need to do to actually instrument them and collect this data? How do I get this in a way that it's usable for me instead of me not having insight or having kind of like gaps in that knowledge? There's things that you could do. New Relic is a full platform that allows you to do that, but it's not the only choice that you have, whether it's something like New Relic or using something like OpenTelemetry that's open source, Prometheus, or any of the other observability vendors. The key step that you want to do here is making sure that you're doing instrumentation, you understand that the data that's being collected, and you have access to it so you can use that for your decisions later. After you've done your initial instrumentation, whether you've deployed an agent or you've done things like using Prometheus, you also want to give second thoughts into what are the key data points that are especially necessary for my team's success. When you're using a vendor or you're using a project out of the gate, they're going to do their best to provide you with industry standards of the type of data that they collect. But then you have to go a step further and truly understand that every team is different, every company is different, our concerns are going to be unique to the service or the product that we're building, and then you go a step further and you do custom instrumentation to add those additional data points, right? Shopping cart totals or things like that that we're not going to be able to give you out of the gate that'll allow you to answer some questions like, if my app is falling over, if I'm experiencing downtime, what does that mean for business impact or revenue? And it's going to be this step of custom instrumentation that you do in your build and deploy phase that's going to give you that additional data point that no provider is going to give you out of the box. From there, you want to start measuring. So you've instrumented, you've deployed your app into production, and you're instrumenting it, which means that you've instrumented, you're running it, and now you want to get a baseline. So it's been running, I'm checking it, I'm getting an understanding of how my application is performing. I'm starting to think about why things are happening. I'm starting to answer questions about like how users are being affected, right? So if I get an idea of what my average response time is or what my average error rate is, and I know that baseline of performance, and it's going to be easy for me to understand when there's anomalies in that data, there's a spike in error rates, right? So something happened and I need to go off and figure out why is there a spike? Or every Tuesday at 2 p.m. we have like a major spike in traffic. I should try to figure out what's causing that additional traffic to come in on those Tuesdays and then put a plan in place on how do we prepare a system to scale in order to meet that demand. Or in some cases, if you're a massive streaming service and the Super Bowl is coming, I know that I have millions of users that are getting ready to get on my platform. What is my plan in order to address these kind of like extra bits of demand that's going to come based off of what my standard baseline is? So that's going to be your next step after you've gone through testing and deploying, is getting a baseline, understanding what your natural state of performance is going to be. And then from your baseline, you start to build things like your SLIs, SLOs, and SLAs, right? So I have an idea of what my standard performance is. I know my tech stack. I've broken it down into different system boundaries. I know my different services and how they're working together. And I have an idea of my company's SLA. So my customers should be able to log in successfully to make a purchase at least 99.97% of the time, or this thing is going to happen. There's some consequence that happens on the back end. Going from that SLA, I address each of my individual services that are working together. So instead of thinking of every single application or my load balancers, my databases as individual units, I want to understand how they're all working together to deliver individual capabilities. So I have a fulfillment service, a login service, a shopping cart service. They're all working together in different units to provide that feature, and I want to monitor them at that level, right? Because our users aren't going to care about the database falling over, but they will care about not being able to log in, and then they're going to go somewhere else. So it's at that level that I really need to be paying attention to the quality of service that I'm providing my users. Right, and so that's mapping out all of your individual pieces together and knowing what performance or what quality of service means for each of those individual sets of components. Right? And then there's also outlying system boundaries that you need to think of as like the overarching experience, and that's where users really care about performance. So rather than only thinking about the different components that are working together to deliver set features, you want to make sure that overall I have this outlying system boundary that is really providing users with that entry-level experience of the app. And we can think about it even yesterday, Instagram went down, right? Logging out thousands of users and sending out over 10,000 notifications that accounts were suspended. And that's at that outlying level of service, right? So that's going to be the point to where people really go into an uproar because they're experiencing such a poor experience. They're going to start to look for other providers or other applications that they could use. So once you've done all of the mapping and you understand your system boundaries, you've instrumented your applications, you've ran them for a while so you can have your baseline, you know what standard performance looks like, then you start creating your SLOs. You get to this middle tier where it's, right now, it's taking X amount of seconds in order for a user to log in order for a response to be returned. And so I want to increase that, or I want to improve that performance. So I'm going to set an objective of every user should be able to log in with a sub 2-second success rate, or a sub 2-second response time of that service. And that's the objective that I'm going to set for this individual service. And if I'm not hitting that, then I know I should go and start making decisions around how to make that service more performant or more reliable. So for every capability that you're building within your environment, you're setting an SLO for each of those fulfillment service, your UI layers, your login service, of what level of service you'd want to provide to your users. And to give an example of that, if it's a credit card processing service, what you want to do is create a definition of what availability means. So credit card payments are processed in an accurate and timely manner, or if it's a front-end service, you want to create a definition of what availability means for that front-end service. Customers can log in, add items to their shopping cart, and successfully place an order. And this is going to be something that's really easy for you to understand or to explain to other stakeholders that may not be technical. And so we know if we're not hitting this statement, if credit card payments are taking too long to process, we're going to lose sales, we're going to lose users. Without any technical knowledge, anyone can understand what availability means for your individual services. And then for your technical people, you think about that statement and you start to break it down into some of the metrics that your application is reporting and how you could use them to make sure from a observability standpoint, we are hitting that availability definition. Right, so thinking about the credit card processing service, saying credit card state payments should be processed in an accurate and timely manner. When you give thought about that, it's like, well, what does accurate mean? What does timely mean? How do we measure this? And then how do we make sure that this is working for our customers, or some of the questions that you want to answer? And as you start to think through that process, using your metrics, it will end up being statements that are measurable based off of the data that's being reported from your application. So for this credit card payments being processed accurate and timely, I'd say for my credit card processing service, my success rate should be 99.5% of the time. 99.95% of the time, I should have a successful payment being processed. And if we start to drop below that 99.95% of the time, then even if it's still running, I know that I'm not providing the right level of service, and my engineers should be thinking about improving the reliability of this software. Or for timely, it's the time between submission and the response is within 3 seconds. So I have 3 seconds in order for that user to click pay and a successful response to be returned. Anything longer than that means that the service is not performing the way that I'd like it to operate, and we should improve its reliability. And then for accurate, it's almost 100% of the time people would expect, if I'm paying $100 for a thing, I want $100 to come out of my bank account, right? We're not going to be understanding if anything more is coming out. So the payment amount and the process amount need to be identical at least 99% of the time. And honestly, something like that would be the payment amount and the process amount needs to be identical 99.999% of the time. You have very low room for error in these instances. But by breaking it down from that very easy to understand definition into these technical metrics that you could use to track, you'll be able to use the data that's being reported from your application to truly understand whether or not it's performing the way that it should, whether the quality of service you're providing to a user is meeting the standards that they expect, and then you can start to make decisions off of that data to think about whether I should be focused on doing reliability work or focusing on the velocity of my roadmap. If we're not meeting these objectives, then maybe we need to scale back on the roadmap and make sure that we're improving the software that we're actually developing. Once you've built those, you want to use a tool that would automatically track your service levels. So this is just a screenshot of, like, in the New Relic platform of how we do SLAs, SLIs, and SLOs, letting you get a visual that you can just throw up on a screen and see. If it's red, I know that I'm violating it. If it's yellow, then there's kind of like an error there. And if it's green, then I'm doing pretty good with regards to the objectives that I set for these individual services. And we're not the only tool to do that, but it's definitely important that you have a programmatic way in order for you to understand what's going on with your service levels and making sure that you're meeting those. And once you've built all of that, you actually have created the system of, you have all of your applications and your services, whether you've developed them or they're open source. You can access the data that's being reported from them, so you understand your latency, your traffic, your error rates, and your saturation. That's going to be the amount of users that are using the app, the way that it's performing, how long it's taking to respond to users. You set an objective, right? So for each of these individual services that I own or that we're developing, this is the quality that we expect to provide to our users, and we have a way in place for us to be able to track those objectives, and we understand our SLA. If we're not meeting our objectives, there's a good chance that we're going to be violating this agreement between us and our users, and that can have legal or financial implications on the back end. All right, and that's going to be the end of my talk. I'm right at 50 seconds. I did pretty good with 15 minutes. I am Jemiah Sius, the head of developer experience at New Relic, Miami native, designer turned software developer. Here is a link to my LinkedIn and Twitter. I am not interesting on either of them, but I'd love to connect with you if you'd all like to connect. And most importantly, thank you so much for your time. I hope you all enjoy yourself here at All Things Open. And if you have any questions around any of the things that I talked about, please feel free to stop me or throw a thing at me, and I'll turn around and try to get you some answers that make sense. Thank you.